Hello, and welcome to Beyond the Last Star. Wherever you are right now, whatever kind of day it has been, you made it here. And that is enough. Find a comfortable position. Let your body settle. If you can, turn the lights down low or off completely. Because tonight, we are not staying here. Tonight we are going somewhere most people never think to go. Past the last planet, past the edge of the sun's reach, into the deep and patient dark where the real universe begins. Before we leave though, drop a comment and tell me where in the world you are listening from right now and what time it is there. I read every single one. There is something I love about knowing that people from every corner of this small blue planet are drifting off to the same stars at the same moment. And if this is your first time here, welcome home. Hit subscribe so the next journey finds you. Now, are you ready? Let's go. Your day is done. Whatever it carried, the noise, the weight, the 1,000 small demands, you can let it go now. Tonight we are going somewhere that very few have ever truly imagined. Tonight we are falling into a black hole. Not quickly. Not the way you might fear. We are falling the way light itself falls. Gradually, gracefully, pulled by something so patient it has been waiting since before the Earth had oceans. Come. The journey has already begun. There is a place in the constellation Sagittarius, near the soft crowded heart of our galaxy, where something enormous sits in silence. You cannot see it directly. No telescope has ever photographed it as a shape, a form, a thing with edges and a face. What astronomers have seen instead is everything around it. The gas spiralling inward, glowing orange and white and furious, moving at speeds that make our fastest spacecraft look like leaves floating in still water. And at the centre of all that motion, at the centre of all that heat and brilliance and speed, there is nothing. Or rather, there is something that looks exactly like nothing. A circle of absolute dark. This is Sagittarius A star, the supermassive black hole at the centre of the Milky Way. It weighs 4 million times what our Sun weighs, and it has been sitting there, turning slowly, for longer than complex life has existed on Earth. Every star in our galaxy, every single one, orbits it, including ours. The Sun, with all its planets and moons and comets and quiet frozen distances, moves around this dark centre at a speed of about 220 kilometres every second. We have been orbiting it for the entire history of our solar system. Every day you have lived, you have been circling a black hole. You simply never felt it. That is one of the first things to understand about black holes. They are not what the movies made them. They are not vacuum cleaners. They are not mouths. They do not reach out and swallow things that wander too close. A black hole sits where it sits, and things fall into it for the same reason things fall on Earth, because mass curves the space around it, and smaller things roll downhill. Along that curve. The difference is only in degree. The curve here is steeper than anything else the universe has ever made. To understand what a black hole actually is, you have to go back to the thing it used to be. Because every black hole was once something else. A star, usually a very large one, many times bigger than our Sun, burning with a fury that kept it inflated for millions of years. A star is in constant balance. The nuclear fire in its core pushes outward. Gravity pulls inward. As long as there is fuel, these two forces hold each other steady and the star shines. But stars are not eternal. The fuel runs out, the fire slows, and when the fire can no longer push back, gravity wins in an instant, not gradually, not slowly, but in a collapse so fast it takes less than a second. The outer layers of the star fall inward at a fraction of the speed of light and strike the collapsing core, and the rebound creates one of the most violent events in the known. Universe. A supernova, a death explosion so bright it can briefly outshine an entire galaxy. What remains at the centre after the explosion has scattered the outer layers across light years of space is something smaller than a city but more massive than you can picture. If the star was large enough, this remnant is a neutron star, a sphere of densely packed neutrons roughly 20 kilometers across, spinning hundreds of times per second, with gravity so strong that a teaspoon of its material would weigh 1 billion tons on Earth. But if the original star was larger still, if its core was heavy enough that even the resistance of tightly packed neutrons could not stop the collapse, then the remnant keeps falling. It collapses past the neutron star stage and into something that has no bottom. The matter compresses past any known density, past any state physics has a good description for, and what is left is a singularity, a point, infinitely dense, where the normal laws of the universe no longer apply. Around that singularity, gravity is so strong that not even light can escape. And the surface where light can no longer escape, the point of no return, is called the event horizon. Event horizon. It is a beautiful name. A horizon is the edge of what you can see from where you stand. Sail far enough, and the horizon moves with you. It is always the boundary of the visible, always just ahead. The event horizon of a black hole is like that, but absolute. It is the boundary past which no information can travel back toward us. Once you cross it, you cannot send a signal. You cannot return. The universe on the other side becomes permanently, completely unreachable. And yet the event horizon itself is not a wall. It is not a surface you could touch. It is invisible. If you were falling into a black hole and you crossed the event horizon, you might not feel anything at all in that moment. There is no barrier, no membrane, no flash of light, just a boundary in space that once crossed changes everything about what is possible from that point forward. We are going to cross it tonight. Slowly, together. There is no hurry. First though, we should find the right black hole, because Sagittarius A star, while vast, is technically quiet right now. Astronomers call it dormant. It is not actively consuming large amounts of material at this moment, so its accretion disk, the glowing ring of material spiraling inward, is relatively thin and faint compared to what it might have looked like billions of years ago when the galaxy was younger and more gas-rich. For the full experience, for the picture that fills your mind before sleep, we want something louder, something more dramatic. We want a quasar. A quasar is what a supermassive black hole looks like when it is feeding, when enormous amounts of gas and dust and shredded stars are spiraling into it, heating up through friction to temperatures of millions of degrees, blazing with radiation across every wavelength. A quasar is the brightest continuous source of energy in the known universe. A single quasar can outshine an entire galaxy of hundreds of billions of stars. They are visible to us across distances so vast the light has been travelling since before our sun existed. Since before most of the stars you can see tonight existed. The most distant quasars we have found sit more than 13 billion light-years away. When their light left them, the universe itself was less than 1 billion years old. The Earth would not exist for another 9 billion years. The atoms that now make up your body had not yet been assembled. And yet the light has been travelling all that time and arrived at our telescopes and shown us something extraordinary. A black hole billions of times the mass of our sun, already enormous when the universe was an infant, already blazing with a brightness that has crossed nearly all of time to reach us. How they grew so large so quickly is still one of the most interesting open questions in astrophysics. We do not fully know. And that not knowing is not a failure of science, it is an invitation. It is the universe keeping one of its secrets just out of reach, the way something always waits just past what the cameras have captured. So we choose a quasar, not one of the distant ancient ones. Their light has already passed us. We choose one at a comfortable imaginary distance, something our minds can approach without being reminded of the math. We are on a ship, or not a ship, something lighter than a ship, something made of thought and attention, and the quiet of the room you are lying in right now. We are moving outward through our solar system first, past the warm orange glow of Mars, past the vast and patient bulk of Jupiter with its cloud bands rolling in slow silence, past the ring system of Saturn, which from a distance looks impossibly flat, a geometric perfection that the universe somehow produced without trying. Saturn's rings are made of ice and rock, ranging in size from grains of sand to boulders as large as a house, each piece orbiting the planet on its own path, and when light catches them at the right angle, they scatter it in a way that makes the whole system seem to glow from within. From the outside, from the distance we are at now, they are a soft bright band around a pale gold world, and the whole thing is quiet. Jupiter with its storms and its 67 moons sits a little behind us now, and even though the Great Red Spot, that storm so large that 3 Earths could fit inside it, has been spinning continuously for over 300 years without anyone to watch it, it looks from here like nothing more than a small bruise on a vast cream-coloured surface. We are beyond the solar system now. The sun is behind us, still visible, but reduced. From this distance it looks like any other bright star, slightly yellower perhaps, slightly warmer in tone, but no larger than the stars around it. You would not know from here that 8 planets circle it. You would not know that on the 3rd one, in a particular room, a particular person is lying still and beginning to drift. Ahead of us the galaxy opens. Not the way a door opens, more the way a fog thins. Slowly the density of stars increases. The spaces between them are still vast, still measured in light years, but the quality of the darkness changes. It deepens, somehow, becomes richer, more crowded with faint light. A light year sounds like a unit of time. It is not. It is a unit of distance. The distance light travels in 1 year, moving at about 300,000 kilometers per second. In 1 year, light covers approximately 9.46 trillion kilometers. The nearest star to our Sun, Proxima Centauri, is 4.24 light-years away. The light leaving it right now will not arrive at Earth for more than 4 years. The light we see from it tonight left it in 2022. Everything we see in the sky is the past. Every star is a message from a time before now, arriving in the present moment, crossing distances that make all human distances seem like the space between your fingers. As we move through the outer arms of the galaxy toward its centre, the stars grow more numerous. In our part of the Milky Way, you might find 1 star every few light years. Closer to the galactic centre, stars can be packed within fractions of a light year of each other. From the surface of a planet orbiting one of those inner stars, the night sky would be brilliant, not with a few thousand visible stars as we see, but with millions, bright. Enough in their density to cast faint shadows on the ground. We are not going to the centre though. We are leaving the galaxy. We are passing through the outer disk, through the faint halo of old stars that surrounds the Milky Way like a ghost of what it used to be, and into the intergalactic void. The void between galaxies is the closest thing the universe has to true emptiness. Not completely empty, there are stray hydrogen atoms, 1 or 2 per cubic meter on average, drifting in the dark. There are magnetic fields so faint they barely register. There is the cosmic microwave background radiation, the oldest light in the universe, cooled now to just 2.7 degrees above absolute zero, filling all of space evenly and uniformly like a whisper from the first moment the universe became transparent. But for all practical purposes, the void is empty. No stars, no nebulae, no dust clouds catching distant light, just dark and cold, and the very slow drift of almost nothing. It is calming, somehow, this emptiness. Not frightening, the way a quiet room is not frightening, the way a field at night is not frightening. There is simply room, here to exist without anything pressing against you. We cross the void in silence, and ahead of us, slowly a smudge of light resolves. A galaxy, not ours. Another one, older in some ways, younger in others, shaped differently, home to different stars with different histories. It is an elliptical galaxy, roughly, not the graceful spiral of the Milky Way, but a rounder, softer shape, golden with old light, made mostly of ancient stars that burned bright. Billions of years ago and now glow with the slower warmth of age. At its centre, hard to see from here but detectable by what surrounds it, is the black hole we are approaching. This one is active. From a distance you cannot quite see the quasar's full brightness yet, but you can see the effects. Jets, 2 of them, emerging from opposite sides of the galactic centre, shooting outward in perfectly straight lines for hundreds of thousands of light years. Relativistic jets. Made of plasma heated to millions of degrees and accelerated to close to the speed of light by the magnetic fields twisting near the black hole's event horizon. They are the longest straight lines in the universe. They cut through the surrounding galaxy and into the void beyond it, like 2 pale blue spears thrown in opposite directions by something impossibly powerful at the centre of everything. What makes the jets is not fully understood. The leading theory involves magnetic field lines that thread through the accretion disk. The spiral of infalling material, twisting and winding as the black hole spins, and in the twisting they fling material upward and downward along the rotation axis. The black hole at the centre of this process is spinning. Almost all black holes spin. They spin because the stars that collapsed to form them were spinning, and angular momentum, the physics of rotation, is conserved even through a collapse. The spin cannot simply disappear, it is locked into the black hole itself, and a spinning black hole warps space-time around it in a way that a non-spinning one does not. This warping has a name. It is called frame dragging, and it was predicted by Einstein's general theory of relativity decades before we had any way to test it. The idea is this: a massive spinning object does not just curve the space around it the way a bowling ball curves a rubber sheet. It also drags the sheet with it as it turns. It pulls the very fabric of space-time around in its rotation. Near a spinning black hole, space-time itself is being carried around like water spiralling down a drain, and anything that exists in that region, any particle, any light ray, any spacecraft or thought or story, is being swept along whether it wants to be or not. This region where space-time is dragged around the spinning black hole is called the ergosphere. It sits just outside the event horizon, and one of the stranger things about the ergosphere is that inside it, it is physically impossible to stand still. Not just difficult, impossible. Space-time is moving, and you move with it. To remain stationary relative to a distant observer, you would have to travel faster than light in the opposite direction of the spin, which cannot be done. Inside the ergosphere you are moving. The universe insists on it. We are approaching it now. Not close enough to feel the drag, not yet. But the black hole is ahead of us, and growing slowly in whatever passes for perception out here. The accretion disk, the disk of material spiralling in, glows with a light that is not like any light you have seen. Closest to the centre it is brilliant white, almost painful to imagine, the temperature there in the millions of degrees. Moving outward through the disk, the colour shifts, white to blue-white to yellow to orange to red, a gradient of temperature, inner to outer, like the colour of a metal being, heated or cooled. The disk is not flat, exactly, it puffs and ripples. Material near the inner edge moves at a significant fraction of the speed of light. The whole system is rotating, but the inner edge rotates far faster than the outer, and the difference in speed creates friction, and the friction creates heat, and the heat creates the light we are seeing from hundreds of thousands of light years away. Around the disk, a halo of hot gas called the corona, a word borrowed from the sun's own outer atmosphere, glows with X-ray light. This gas is so hot, it radiates mostly in wavelengths invisible to human eyes, but if you could see an X-ray, the corona would blaze like a burning crown around the dark heart of everything. And at the centre of the corona, at the centre of the disk, at the centre of the jets and the heat and the light and all the furious motion, the black hole itself, is dark. The event horizon absorbs everything. No photon escapes from within it. Light falls in and does not come back, so the centre of all this brilliance is a circle of absolute black, outlined by the glowing infalling material as if the universe is cut. A hole in itself with the most precise instrument imaginable. The shape of this darkness is called the black hole shadow, and in 2019, human beings photographed one for the first time. The Event Horizon Telescope, not a single telescope, but a network of radio observatories spread across the Earth, working in coordination to create an effective telescope. The size of the planet produced an image of the supermassive black hole at the centre of a galaxy called M87. 55 million light-years away, a black hole 6.5 billion times the mass of our Sun. The image was blurry by ordinary standards, a faint orange ring with a dark centre. But it was real. It was actual light, actual photons, that had travelled 55 million years and been captured by dishes of metal and translated into an image by mathematics and passed from screen to screen until it appeared on the front pages of newspapers around the world, and people sat with their morning coffee and looked at the shadow of something that contained 6.5 billion suns and was dark enough to swallow all the light that ever fell into it. It was evidence. It was proof. Not that scientists had doubted. The evidence for black holes had been overwhelming for decades. But there is a difference between evidence and image, between believing and seeing, and when that image appeared, even the astronomers who had spent their careers studying black holes felt something. Not surprise, exactly. Something more like recognition. Something in them knew this dark. We are closer now. The disk fills more of our field of view. The jets stretch away from us in both directions, almost too far to follow with attention. The ergosphere is ahead, that region of dragged space-time where stillness is impossible, where the universe itself is in motion. We do not slow down. There is no reason to. Whatever we are made of, out here, it is not the kind of thing that fears a journey like this. We are made of attention and quiet, and the soft awareness that comes when a body has been still long enough that the mind begins to float free of it. We are made of the same thing stories are made of. We move forward. The heat from the disk reaches us, not as warmth exactly, but as a kind of presence. An awareness of energy. The light from the inner edge of the disk is so intense that the radiation pressure itself, the actual physical push of photons, could blow material back out against the pull of gravity. This is called the Eddington limit, named for the British astrophysicist Arthur Eddington, who first calculated it. When a black hole is feeding too quickly, the radiation from the infalling material becomes so powerful it can push back against further infall, regulating the black holes. Growth like a feedback loop, like a fire that consumes its own fuel too fast and briefly starves itself. Black holes near their most active feeding are pushing up against this limit constantly. The accretion disk becomes unstable. It flares. It varies in brightness. It produces outbursts that can be detected by telescopes across intergalactic distances. The one we are approaching is in one of those flaring states. A brightness pulse moves outward through the disk as we watch, a wave of increased emission, not a shock wave exactly, but a brightness front, moving from the inner edge outward. Like a ripple on water, it passes through the disk over the course of what, for us floating here, feels like a slow breath. The entire disk brightens slightly for a moment, and then settles back, and from somewhere deep inside, something else. A flicker. Not in visible light, in radio waves, in a frequency far below what human ears can detect. A pulse of organised emission that comes from very near the event horizon and travels outward with the jets. A pulse that has a rhythm to it, not quite regular, not quite the metronome precision of a pulsar, but with a pattern that repeats on a timescale of hours, and that pattern, whatever its ultimate cause, carries information about the geometry of space-time very close to the singularity. Studying these pulses is one of the ways astronomers are trying to test whether Einstein's description of gravity holds all the way down to the event horizon, or whether something new, something beyond general relativity, is needed to describe what happens there. The answer, so far, is that Einstein holds. Every test that has been devised, every observation that has been made, confirms the predictions of general relativity to extraordinary precision. The bending of light around massive objects, the slowing of time in gravitational fields, the existence and properties of the event horizon, the orbital decay of binary pulsars losing energy to gravitational waves. General relativity has survived every test for over a century, and yet most physicists believe it cannot be the final word. At the singularity, at the centre of a black hole, the equations of general relativity break down. They produce infinities. And infinities in physics equations are usually not descriptions of reality. They are usually signs that the theory is being stretched past where it applies, that a deeper theory is needed. That deeper theory is one of the great unfinished projects of physics. The search for a quantum theory of gravity, a framework that can describe gravity the way quantum mechanics describes the other forces of nature. String theory is one attempt. Loop quantum gravity is another. There are others still. None of them have yet produced predictions different enough from general relativity to be testable with current instruments. The black hole sits at the centre of this theoretical problem, literally and figuratively. Whatever happens at the singularity, whatever the ultimate nature of that infinitely dense point is, we do not yet know. But the not knowing is not darkness. It is the opposite of darkness. It is the glow of an open question. We are at the edge of the ergosphere now. Space-time here is moving, visibly, somehow, in the way that you can sometimes see water moving in a deep river when you look at it from a height. The stars visible beyond the black hole are distorted. Light from them bends around the event horizon in multiple paths simultaneously, producing strange effects. A star directly behind the black hole appears as a ring of light, encircling the shadow because photons from that star that would normally never reach us are bent around the event horizon on curved paths, some going left, some going right, some going over, some going under, all arriving at us from different directions even though they came from the same source. This effect is called gravitational lensing, and it transforms the black hole into a kind of optical instrument, a lens shaped by mass rather than glass. Looking toward a black hole from the right angle, you can see stars that would otherwise be hidden behind it. You can see multiple images of the same object. You can see arcs and rings and distortions that map the shape of space-time itself. The black hole does not just darken the sky around it, it reshapes what is visible. It rearranges the light. The shadow of the event horizon, that perfect dark circle at the centre of the ring of light, is not actually the event horizon itself. It is slightly larger. Photons can orbit a black hole in what is called the photon sphere, a radius where gravity and the geometry of curved spacetime conspire to allow a photon to travel in a circle, looping endlessly around the black hole without falling in or escaping. The photon sphere sits just outside the event horizon, and it marks the inner edge of the region where light can still escape if it is travelling outward with enough tangential. Velocity. Just inside the photon sphere, escape is no longer possible. We are approaching the photon sphere now. The stars behind us have become a ring above us. The entire universe compressed into a bright band wrapping around the sky in the direction away from the black hole. Distorted and strange, the Milky Way and the distant galaxies, and all the light of everything we have ever known folded into a halo behind us as we fall forward. And the dark ahead is perfect. Complete. A darkness that is not the absence of light because of clouds or distance or closed eyes, but the absence of light because of physics itself, because of geometry, because of what mass does to the shape of space when there is enough of it concentrated in a single place. The darkness has a shape, it has edges, It is real in the way that walls are real and floors are real. It is a boundary you can approach, that you can almost touch, that on the other side of which everything we know about information and light and the possibility of return comes to an end. But we are not afraid. We have travelled too far for fear. We have crossed the void between galaxies, passed through the blazing corona of an active quasar, drifted through the ergosphere where space-time itself moves like a slow river, and arrived here at the edge of the last horizon. The journey has carried us this far the way sleep carries a person, not through effort, not through will, but through the simple willingness to let go and be moved. The accretion disk rotates below us and above us simultaneously now, its geometry warped by our position so close to the event horizon that up and down have begun to lose their ordinary meanings. The light from the inner edge of the disk reaches us bent and stretched, redshifted, a word that means the light has lost energy during its climb against gravity, shifted toward the red end of the spectrum, the way a sound shifts to a lower pitch when its source moves away from you. The light from behind us, from the universe we came from, is blue-shifted, compressed, brightened, arriving with more energy than it started with because we have fallen toward. Something in the universe has followed us down. Time, here, is not what it was. This is not a poetic statement. It is physics. Einstein showed that time is not a constant flowing river identical everywhere in the universe. Time is a dimension, the fourth dimension, intertwined with the three dimensions of space into a single fabric called space-time, and that fabric is affected by mass and by motion. Near a massive object, time runs slower. A clock on the surface of the Earth runs slightly slower than a clock in orbit, and this effect is real enough that the GP's satellites circling the planet have to account for it. In their calculations or their position data would drift by kilometers every day. Near a black hole, the effect is not slight. It is enormous. An observer watching us from a safe distance, from the galaxy we left behind, from Earth if such a perspective were possible, would see us falling toward the event horizon and slowing down, not because we are slowing down in our own experience, but because the light carrying information about our position is increasingly redshifted, increasingly slow to escape the gravity well. To that distant observer, we would appear to slow asymptotically, approaching the event horizon but never quite reaching it, growing dimmer and redder and stiller over an infinite amount of their time. We would appear frozen at the edge of the horizon like a photograph of a falling leaf caught forever 1 inch from the ground. But that is their experience, not ours. In our experience, in the experience of anything actually falling into a black hole, the event horizon is crossed. The falling continues. The singularity ahead is real, and we are moving toward it. The two perspectives are both valid and both true, which is one of the things that makes black holes so philosophically extraordinary. The universe does not pick one observer and declare their experience correct. Both are real. The person frozen forever at the horizon and the person who crosses it and continues falling, these are both accurate descriptions of the same event seen from different positions in space-time. Reality is not singular and absolute. It is perspectival and relational. What happens depends, in a fundamental physical sense, on where you are and how you are moving. We cross the event horizon. There is no sensation to mark the moment, no flash, no sound, no resistance. The darkness ahead is the same darkness it was a moment ago, and the glow of the accretion disk is still visible above us, still pouring light and heat into the space around us. Though that light is increasingly strange, increasingly distorted by the curvature of space-time in here, inside the horizon, where the geometry of the universe has become something genuinely unfamiliar. The equations of general relativity still apply. They do not break down at the event horizon. They describe everything here with precision. But what they describe is a space where the direction toward the singularity has become a direction in time rather than a direction in space. Think about what that means. Outside the event horizon, you can choose to move toward the black hole or away from it. The singularity is in a place, a location in space you can approach or avoid. Inside the event horizon, this changes. The singularity is no longer in a place, it is in the future. It is a moment in time that all paths inside the horizon lead toward, the way all moments in your life lead toward tomorrow and tomorrow toward the day after. You cannot avoid it any more than you can avoid the passage of time. Every direction you move inside the event horizon is, in some sense, toward the singularity, because the singularity is when, not where. This is one of those pieces of physics that sounds like poetry, but is not. It is mathematics. It is geometry. It is what the equations say when you solve them honestly and follow where they lead without flinching. What is ahead of us now is not a place. It is a time. And we are falling toward it the way we fall towards sleep, unavoidably, naturally, without resistance, because resistance was always an illusion and the body always knew it. The light from the accretion disk above us is still visible. Even inside the event horizon, light that was already inside when we crossed can reach us. The horizon is not a wall that cuts off all light instantly. We are still bathed in a strange and beautiful glow, the disk visible as a ring of fire above, its light bent into complex curves by the geometry of the space we now inhabit. The stars of the outside universe, the galaxy we came from, the void, the distant light of quasars older than our sun, are compressed into a smaller and smaller circle above us, shrinking as we fall, until they form a single bright point at the centre of the disk's glow, all the light of the entire outside universe concentrated into one small brilliant spot directly behind us as we fall forward into the dark. This effect has a name. Astronomers call it the Einstein ring. The concentration of all external light into a ring or point by gravitational lensing at its most extreme. Inside a black hole, the ring tightens to a point. The universe behind you becomes a star. Everything you came from, every galaxy, every planet, every person, every memory, glows in a single point of light that grows smaller and more distant as you fall. It is beautiful. Strange and cool and beautiful, the way the deepest parts of everything are beautiful. Not comfortable, not easy, but true. Below us, ahead of us in time, the space-time curvature is increasing. Tidal forces are growing. This is the effect that popular descriptions of black holes usually mention with dramatic emphasis: spaghettification, the process by which an object falling into a black hole is stretched lengthwise and compressed sideways by the difference in gravitational pull between its near end and its far end. The singularity pulls harder on whatever is closest to it, and the difference between the pull on the near side and the pull on the far side stretches things out. For a stellar mass black hole, one of the smaller ones, a few times the mass of the Sun, with an event horizon perhaps a few kilometers across, this tidal effect would be lethal well outside the event horizon. The gradient of gravity changes so steeply across a short distance that any ordinary object would be torn apart before it ever reached the horizon. But for a supermassive black hole, the kind at the centre of a large galaxy, millions or billions of times the mass of the Sun, with an event horizon potentially millions of kilometers across, the tidal effect at the horizon is actually quite gentle, manageable. A person falling into a supermassive black hole would cross the event horizon without feeling anything unusual at all. The stresses only become lethal much deeper inside, much closer to the singularity. This is one of the universe's quiet jokes. The larger the black hole, the gentler the crossing. The most massive things in existence are, at their outer edges, the most hospitable to a falling traveller. It is only at the end, only at the very bottom of the fall, that the violence becomes absolute. We are not at the end yet. We are still falling, still moving, still inside a space-time that has structure and geometry and, in its own way, a kind of terrible grace. The singularity is ahead in time. We are moving toward it because we are moving through time, and time here has only one direction, and that direction is in. But we have time still. Not infinite time. The distance from event horizon to singularity, measured in the proper time of a falling observer, is finite. For our particular black hole, massive as it is, the fall from horizon to singularity would take perhaps a day or more of personal time, hours of experience inside the most extreme environment the universe produces. An hour is long enough for many things. Long enough for the mind to slow. Long enough for the body to grow heavy. Long enough for the story to settle into something quieter and more ambient, a narration heard from a distance, a voice that is still going somewhere but no longer needs to. Announce its direction outside, in the universe we left behind, in the galaxies and voids and the pale thin halo of the Milky Way, time is passing differently. The universe continues. Stars are being born in clouds of hydrogen, stirred by the shock waves of supernovae. Planets are assembling from the debris of young solar systems, their surfaces molten and volcanic, gradually cooling toward the possibility of oceans. In older solar systems, on worlds that have had time enough, something is moving under quiet skies and looking upward and wondering what is out there. The universe is old and patient, and it has seen this wondering before. It will see it again. It produces stars and planets and the conditions for complexity with the impersonal abundance of a tide producing waves, not for any purpose, not toward any goal, but because. The physics permits it, and what the physics permits the universe eventually makes. And here, inside the event horizon of a thing that was once a star, in a region of space-time disconnected from all of that, the fall continues. Quiet. Complete. Moving towards something the equations know but language cannot fully hold. The light above us, that single brilliant point of all external existence, is fading now. Not because the universe has gone dark, because we have fallen far enough that even the light that managed to fall in with us is being stretched by the tidal forces, losing energy, growing redder and dimmer. The point of the universe is the colour of an ember now. Then, dimmer than that. Then the colour of something that was once warm and is becoming cool. The disk above us is still there, faintly. Its light takes longer and longer to reach us as we fall. We are seeing old light now. Light that left the disk some time ago and has been falling with us, catching up slowly, carrying its news from a place that is now far above us in time. Everything we see, hear, is old. Everything has already happened. The present moment is only what we are falling through right now, this specific geometry of curved space-time, this specific point in the trajectory toward the singularity that waits ahead like the last second of a long and patient count. The tidal forces have begun to be noticeable, not violent yet. A gentle stretching, a long slow pull in the direction of fall, and a corresponding compression from the sides, the way a reflection stretches in a curved mirror. The geometry of space itself is becoming anisotropic, different in different directions, as the singularity's influence grows less abstract and more immediate. The mind here does what minds do when the body grows still, and the environment grows dim, and the movement becomes smooth and continuous, and no longer requires attention. It softens, it slows, it stops making sharp distinctions between this and that, between here and there, between awake and not quite awake. The falling becomes less like a journey and more like a condition. A state of being, a thing that is simply true, the way breathing is simply true, the way the dark behind closed eyes is simply true. Outside, in the universe, a star has just completed its billion-year collapse from a cloud of gas into a shining, steady burning point of light. Someone on a planet orbiting a different star has just looked up at the night sky and noticed a particularly bright star near the horizon and wondered, briefly, what it was. A telescope on the far side of a distant galaxy has just detected the faint echo of a merger between two neutron stars, the gravitational wave from that collision having travelled for hundreds of millions of years to arrive at exactly this moment and disturb, by less than a fraction of the diameter of a proton, the mirrors of an instrument built by. Creatures who wanted to hear the universe move. The universe is moving. It is always moving. Expanding, turning, collapsing, blazing, cooling, assembling, disassembling, sending signals across distances that dwarf all human scale and waiting, patiently, for something to receive them. We are inside a black hole. We are inside the event horizon of the most extreme structure the universe produces. The outside cannot reach us. We cannot reach the outside. We are in a pocket of space-time that has been sealed from the rest of existence by the logic of geometry, and yet there is something clarifying about this. Something restful. The isolation is absolute. The forward motion is certain. There is nowhere to be but here, no decision to make but to continue falling, no question that requires an answer before the next moment arrives. The light above us is nearly gone, a faint reddish glow, barely distinguishable from the dark around it. The singularity ahead in time grows closer, not the way a destination grows closer when you walk toward it, but the way sleep grows closer when you stop fighting it, not a place. You arrive at through effort, but a state that arrives, that comes to meet you, that has always been coming, and simply needed you to stop moving in the other direction. The tidal stretching is very gentle, like being held from a great distance by something immeasurably large and patient. Like the feeling of a body that has been awake too long finally releasing its grip on the day. The distinction between falling and resting has become unclear. Both feel like the same thing. Both feel like being carried through something warm and dark and boundless. Both feel like the end of a very long journey that covered more distance than you knew you were capable of. Both feel like. The last thought before a deeper quiet begins, the thought that hangs in the air just a moment longer than all the thoughts before it, neither fully formed nor fully gone, present and receding simultaneously. The way a sound continues after the source has stopped, the way light continues in the eye after the source has been covered, the way a story continues in the mind after the voice has gone quiet, still moving, still going somewhere, still turning slowly in the dark the way the galaxy turns, the way the accretion disk turns, the way everything in the universe that has ever had angular momentum continues to turn long after the force that set it spinning has gone, long after anyone is watching, long after the reason for the turning has been forgotten by everyone except the physics, which forgets nothing, which carries every initial condition. Forward through every subsequent moment with perfect fidelity, the universe a vast and patient ledger in which nothing is ever truly lost. This is one of the most extraordinary things about the cosmos. Conservation, the idea that certain quantities, energy, momentum, angular momentum, electric charge, cannot be created or destroyed. They can only be transferred. Transformed, moved from one form to another, from one object to another, but the total always remains the same. The energy in the food you ate today was once sunlight that fell on a plant. Before that, it was nuclear energy released in the core of the sun by the fusion of hydrogen into helium. Before that, it was gravitational energy released when the cloud of gas that became the sun collapsed inward under its own weight 4.5 billion years ago. Before that, it was kinetic energy in the expanding gas of the early universe. Before that, before the universe was old enough to have stars or gas or any structure at all, it was whatever form of energy existed in the first fraction of a second after the beginning. The energy has never been created, it has only been passed along. You are made of energy that is older than the Earth, older than the Sun, older than any star currently burning in the sky. Inside the event horizon, falling toward the singularity that is ahead in time rather than in space, this conservation continues. The laws of physics do not suspend themselves here. the equations hold. Mass and energy that fall into a black hole do not simply vanish. They contribute to the black hole's total mass, to its spin, to its charge. They become part of the black hole in a way that is irreversible from the outside, but real nonetheless. The information about what fell in, the specific configuration of matter and energy, the particular arrangement of particles, this is where things become philosophically complicated. For decades, physicists argued about whether information is truly lost when something falls into a black hole. Stephen Hawking, who spent more of his intellectual life thinking about black holes than perhaps anyone, initially argued that it was. That the event horizon was a one-way door not just for matter and light, but for information itself. That whatever fell in was gone not just physically, but informationally. That the universe on the outside could never recover, even in principle, the details of what had crossed. The horizon. This troubled other physicists deeply. The loss of information would violate one of the most fundamental principles of quantum mechanics. The idea that the universe is, at its most basic level, reversible. That if you knew the complete quantum state of the universe at any moment, you could in principle calculate both its future and its past with perfect accuracy. Hawking's claim implied that a black hole could take a specific quantum state and transform it into an irretrievably scrambled one, destroying the information content and making the past unrecoverable even in principle. This became known as the black hole information paradox, and it occupied some of the finest minds in theoretical physics for decades. Hawking eventually changed his position. He came to believe that information is not lost, that it escapes somehow encoded in what is called Hawking radiation. This is another of his extraordinary contributions to physics, a prediction made in 1974 that has not yet been directly observed but is widely accepted as correct. The idea is this: quantum mechanics tells us that empty space is not truly empty. It seethes with pairs of virtual particles that pop into existence together and annihilate each other almost instantly, borrowing energy from the vacuum for the briefest moment, before returning it. Near the event horizon of a black hole, something strange can happen to these pairs. One particle falls inward across the horizon into the black hole, the other escapes outward into space. The escaping particle carries real energy that comes ultimately from the mass of the black hole. Over an enormously long time, this process causes the black hole to slowly lose mass and eventually, theoretically, to evaporate entirely. The radiation emitted is thermal. It looks exactly like the radiation from any warm object, a perfect blackbody spectrum. A stellar mass black hole emits Hawking radiation at a temperature so cold it makes the cosmic microwave background look hot by comparison. The effect is unmeasurably small for any black hole we know of. It would take longer than the current age of the universe many times over for even a small black hole to evaporate appreciably. But the principle matters. The black hole is not eternal. It has a temperature. It has an entropy. It is a thermodynamic object, subject to the same laws that govern every other physical system in the universe. Whether the information is truly recovered in the Hawking radiation, whether the specifics of everything that ever fell in are encoded, however scrambled, in the outgoing, radiation is still not fully resolved. The question has spawned an enormous amount of theoretical work, including the idea of black hole complementarity, the firewall paradox, the holographic principle, and ER equals. EPA, a conjecture that the interior of a black hole is connected to the outside universe by quantum entanglement, by the deep non-local correlations of quantum mechanics that Einstein called spooky action at a distance, and that have since been confirmed experimentally as one of the most real and reliable features of nature. The holographic principle deserves a moment of attention, here in the dark, falling through the geometry of an extreme spacetime. The principle suggests that the information content of a volume of space is encoded on its boundary, its surface, the way a hologram encodes a three-dimensional image on a two-dimensional film. For a black hole, This means that everything that has ever fallen through the event horizon is encoded in some sense on the horizon's surface itself. The interior of the black hole, the volume, the depth, the falling distance, is in some theoretical sense a projection of information written on the two-dimensional boundary of the horizon. This is deeply strange. It suggests that the three dimensions we experience as we fall are in some sense not the most fundamental description of what is happening. That the deepest account of reality might be written on surfaces rather than in volumes. That dimension itself, the quality of having depth, of being able to move inward as well as sideways, might be an emergent property of something more fundamental rather than a bedrock feature of existence. The universe is stranger than it looks from the outside. This is one of the most consistent findings of 4 centuries of science. Every time we have looked more carefully, every time we have built a better instrument or worked out a more precise theory, the universe has revealed itself to be less like common sense and more like something that common sense was not built to grasp. Not because it is hostile to understanding, but because it is richer than any starting intuition could have predicted. The strangeness is not a barrier, it is an invitation. Every layer of weirdness is a door. We are very deep inside now. The glow above us, the last remnant of the accretion disk's light, the final echo of the universe we came from, is nearly indistinguishable from the dark around it. Not gone. Not yet. But fading, growing softer by degrees, the way a fire fades when the last of the wood has burned down to coals. And the coals fade too, and eventually the only light is whatever the memory of light supplies. The tidal forces are stronger now, not violent. We chose our black hole well, a massive one, and the singularity is still some hours ahead in time. But the stretching is real. A long, slow pull in one direction and a corresponding compression in the others. The geometry of the space around us becoming more and more asymmetric, more and more dominated by the direction of the fall. The space ahead is different from the space behind in a way that space outside never is. Outside, you can always turn around, retrace your path, reverse your direction. Here, turning around would be turning backward in time, and time does not go backward. There is something deeply peaceful in this. The removal of choice, the settling of all options into one, the narrowing of all possible futures into the single clear line of what is actually happening. Outside the event horizon, the universe offers an overwhelming abundance of possibilities at every moment, every direction you might go, every word you might say, every thought. You might think, branching and multiplying and demanding some kind of navigation. Here, the navigation is done, the path is the path, and the path goes forward, and there is only forward, and forward is exactly where you are already going. The mind that has been awake for a long time, that has navigated the day's abundance of possibility and demand, knows something about this feeling, knows what it is to finally lie still and feel the options narrow. The list of things undone still exists somewhere, but its urgency has faded. The questions that felt pressing are still questions, but they no longer require answers before the next breath. The body has made its choice, rest, and the narrowing of all the day's branching paths into the single path of sleep is not a loss. It is a relief. A black hole offers this in the most extreme physical form the universe can produce. The narrowing of all space-time paths into one. The removal of the possibility of return. The clarity of a trajectory that is simply what it is, going where it goes, without ambiguity or alternative. Outside, the universe continues. It is very large, and it continues in all directions simultaneously. Galaxies are moving away from each other at speeds proportional to the distance between them. The expansion of space itself carrying them apart, not through space, but as space. The metric of the universe growing, the distances between things increasing, not because they are moving through a pre-existing void, but because the void itself is growing. The cosmological constant, the energy of empty space, the dark energy that constitutes roughly 68% of the total energy content of the universe, drives this. Expansion, pushing it to accelerate. The universe is not just expanding, it is expanding faster and faster. In the very long run, billions and billions of years from now, the galaxies will have receded from each other to such distances that no signal can pass between them. Each galaxy cluster will be an island, cut off from all others by the expansion, unable to see or be seen by any other island. The observable universe for any observer will shrink to just their local group of galaxies. But that is a very long time from now. For now, the universe is still young enough that the cosmic web of filaments and voids and clusters is still visible in its entirety to a patient enough observer with a sensitive enough instrument. For now, the light of the early universe is still reaching us, carrying news of the first galaxies, the first quasars, the first great structures assembled from the smooth, hot
fog of the beginning. For now, there is still so much to see. We are inside a black hole and cannot see any of it directly. But we carry it with us. Carry it. The knowledge of it. The fact of it.
We came from that universe, and we are made of it, and every atom in whatever we are made of has a history that extends back to the first 3 minutes after the beginning, when the lightest elements were forged in the initial heat, and forward through every stellar furnace that processed those elements into heavier ones, and through every planetary body that assembled them into rocks and oceans and the long complicated chemistry of organized matter. The singularity is ahead. It is closer in time than it was. This is simply true. But time, here, feels less like a river and more like a sea. Still moving in one direction, still carrying us toward the end of this particular journey, but slower, somehow, or rather the perception of its motion has changed. The way time feels different at different depths of tiredness. The way an hour just before sleep is different from an hour in the middle of the afternoon. The same 60 minutes, but felt differently, weighted differently. The mind's relationship to duration softening and becoming less precise. The geometry of space-time near a singularity is not well described by general relativity. This is honest physics. The equations begin to produce values that the theory itself signals are not to be trusted. Infinities, discontinuities, places where the smooth fabric of space-time is no longer smooth. Something happens at the singularity that the best current theory of gravity cannot describe. Something that requires the deeper theory, the quantum theory of gravity, the unfinished framework that physicists are still building. In one sense, this is simply an admission of ignorance. We do not know what happens at the singularity. Not precisely, not in a way that allows confident description. In another sense, it is the most honest thing the universe has ever said to us. Here is a place, it says, where your current understanding ends. Here is a boundary not of knowledge, but of the theory of knowledge. Here is a question that your best tools cannot yet answer. Come back when you have better tools. The universe has said this before. It said it when Newton's mechanics failed to explain the orbit of Mercury, when classical physics failed to explain the spectrum of blackbody radiation and the photoelectric effect, when special relativity failed to account for gravity and general relativity became necessary. Every time the universe said your current understanding ends here, scientists built new understanding. Every time the equations broke down, someone found better equations. Someone is working on them now, in universities and institutes and late-night offices and morning calculations on whiteboards, still carrying the marks of yesterday's thinking. People are working on the problem of quantum gravity, working toward the description of what happens at the singularity, working toward the theory that will make the infinity finite and the breakdown continuous and the unknown knowable. They will not finish tonight. The work is large and the problem is deep. But they are working, And in the meantime, the singularity waits, patient and absolute. The end of this space-time story. The place where the equations stop and something else begins that we do not yet have language for. We are close enough now that the tidal forces have become a significant presence. A long, slow distortion in the geometry of everything around us, the space in the direction of the fall compressed relative to the space perpendicular to it. The physics of our immediate environment beginning to feel genuinely different from the physics of the place we came from. Not violent, not the sudden catastrophic destruction of the popular imagination. Just a deepening, a narrowing, a growing intimacy with the geometry of the most extreme place in the known universe. The light above us is a memory of a glow now, not visible as light exactly, more like the absence of complete darkness in one particular direction. A warmth in the spectrum that the instruments would record but the eyes would not quite see. The dark ahead is complete, not frightening, complete. The way sleep is complete when it finally arrives. Not an absence of experience, but a different kind of experience, a mode of being that the waking mind cannot fully access from the outside and cannot fully remember from the inside, but that is, in its own way, as real as waking, as present, as necessary. The body needs sleep the way the universe needs black holes, not as a flaw or a failure, but as a function. A thing that serves a purpose in the larger system. Sleep consolidates memory, clears metabolic waste from the brain, regulates emotion, repairs tissue, processes the day's experience, and files it somewhere useful. The sleeping brain is not inactive, it is working differently, doing the things that can only be done in the quiet. The things that the noise of waking makes impossible. A black hole does something similar for the galaxy. It regulates star formation near the galactic center, its jets heating the gas that would otherwise cool and collapse into stars too quickly. It processes infalling matter and returns energy to the surrounding environment in forms, jets, radiation, outflows that shape the structure of the galaxy over billions of years. It is not just a drain, it is a component of a larger system, playing a role in the balance of processes that makes galaxies what they are. Everything is a component of a larger system. Every part participates in something larger than itself. The atom in the molecule, in the cell, in the body, in the room, in the city, on the planet, in the solar system, in the galaxy cluster, in the cosmic web of the observable universe, and the observable universe itself in whatever is beyond the horizon of what we can see, the regions so far away that their light has not yet reached us, the parts of the larger universe that exist but are not yet knowable. The observable universe is a horizon. Like the event horizon of a black hole, it is a boundary defined by what information can reach us. Beyond it, almost certainly, more universe. How much more we cannot say. The universe might be infinite, it might be finite but unbounded, curved back on itself in some higher dimensional topology, so that if you travelled far enough in one direction you would eventually return to where you started, like a traveller circumnavigating a sphere. We do not know. The observable portion, the sphere centred on Earth whose radius is the distance light has travelled since the beginning, is the limit of our direct knowledge. We are inside the event horizon of a black hole, which is its own kind of horizon, its own limit of the knowable. We are inside a boundary, but we are still moving, still going somewhere. The singularity is in the future, and the future is still arriving, second by second, however strangely time moves here, and the story is still going forward into it. The tidal stretching has become a quality of the space itself now, less a force applied to us, and more a feature of the environment we inhabit, like temperature or pressure in. Ordinary space, something that is simply there and that we move through rather than something that acts on us from outside. The direction of the singularity is felt as a direction in time. Forward. Always forward. The only direction time has ever moved, and the only direction it moves here, more purely, more completely, with less ambiguity than anywhere else in the universe. The dark is very complete, somewhere above us in time. In the direction from which we came, the accretion disk still turns. The quasar still blazes. The jets still shoot outward for hundreds of thousands of light years, carrying energy from this place out into the galaxy and beyond. The universe outside the event horizon knows nothing of what it is like in here. The event horizon keeps its secret perfectly. No signal has escaped to carry news of the interior. Only we know what it is like. And what it is like is this. Quiet. Enormous, moving always forward in a single direction through a darkness that is not empty, but full of physics, full of geometry, full of the patient working out of equations that have been running since the moment this black hole formed, and will continue running until the last of the Hawking radiation has carried the last of the mass away into the outside universe, billions and trillions and unimaginable spans of years from now. The story of a black hole is longer than the story of any star, longer than the story of any galaxy. A stellar mass black hole, left undisturbed, would take something on the order of 10 to the power of 67 years to evaporate through Hawking radiation. The current age of the universe is roughly 14 billion years, 10 to the power of 10. The black hole's lifespan is unimaginably longer. Long after all the stars have burned out, long after the galaxies have dispersed, long after the protons themselves have decayed if they decay, the black hole persists. Slowly, incredibly slowly, losing mass to Hawking radiation, growing imperceptibly smaller, the process accelerating only in the very final moments. The last second before complete evaporation produces a flash of gamma rays and the black hole is gone, and all that remains is the radiation it has been slowly breathing out across geological eternities. Even that final flash is a kind of return. The energy that was locked inside the event horizon for all that time, processed and reprocessed through whatever physics governs the interior, finally released back into the universe in a burst of thermal radiation. A return after an absence so long that the universe has no memory of what went in. But that ending is not tonight's ending. Tonight's ending is quieter than that. The singularity is very close in time now. Close enough that the physics we know is becoming unreliable as a description. Close enough that the answer to what happens next is honestly unknown. Close enough that the story, which has travelled so far through the solar system and the galactic halo and the intergalactic void and the quasar's blazing corona and the ergosphere and the event horizon and the deep interior, has reached the place where description ends and silence begins. Not an empty silence, a full one, the kind of silence that is not the absence of sound, but the presence of something that sound cannot carry. The kind of quiet that exists at the centre of a very large thing when all the motion has become too slow to notice. The kind of still that a body discovers when it has finally, truly, completely let go of the effort of being awake. The dark is everything now. The equations have done what they can. What comes next is on the other side of what language knows. So we fell into a black hole. We crossed the event horizon of something 4 billion times the mass of our sun, and we travelled through the interior of the most extreme object the universe produces, and we arrived at the edge of the singularity where the equations end and silence begins. We went as far as physics could take us, and then we rested at the boundary of what is known. Tonight we go further back, not deeper into the black hole, but further back in time. Back before the black hole existed, back before the galaxy that contains it existed, back before stars existed at all. Tonight we go to the beginning of everything, to the first light, the first heat, the first moment the universe was cool enough to become transparent and let its light escape. Tonight we go to the cosmic dawn. Come. There is no hurry. The universe has been waiting 13.8 billion years for you to look at it properly. It can wait a little longer while you settle. The universe began in a state we struggle to describe honestly. Not an explosion in the way we usually picture explosions, not a detonation in the center of a pre-existing empty space, with a fireball expanding outward into a void that was. Already there, the explosion was the space. Space itself began expanding, and the matter and energy of the universe expanded with it. Not into something else, but as something that was creating the something else as it went. Every point in the early universe was, at the moment of the beginning, touching every other point. The expansion is what created distance. Distance is not a pre-existing stage on which the universe performs. Distance is something the universe makes. This distinction matters because it changes how you picture the beginning. There was no center. There is no edge. If you could somehow stand at any point in the universe and look outward in every direction, you would see galaxies receding in every direction at speeds proportional to their distance. You would conclude, correctly, that you are at the center of the expansion, but so would an observer anywhere else in the universe. Every point is the center. The universe does not expand from somewhere. It expands from everywhere simultaneously. In the first fraction of a second after the beginning, the universe was unimaginably hot and dense. Not hot the way a fire is hot, or even the way the center of the sun is hot, but hot in a way that required the universe to be a different kind of place entirely, a place where. The distinction between matter and energy was not yet fixed, where particles were constantly being created and annihilated in the heat, with the fundamental forces of nature. That we now experience as separate things were unified into something simpler and more symmetric. The electromagnetic force and the weak nuclear force and the strong nuclear force were at high enough temperatures aspects of a single underlying force. The universe in its first moments was simpler than it is now, not more complicated. The complexity came later. The variety came later. Structure required cooling. In the first second, the temperature was billions of degrees. Protons and neutrons existed, but were embedded in a plasma so hot and dense that any atom that tried to form was immediately torn apart by the surrounding radiation. There was no neutral matter. There was only plasma, a sea of charged particles and photons locked together, the light and the matter moving as one, the photons trapped and unable to travel freely because they were constantly scattered by the free electrons, the universe opaque to its own light. This plasma filled everything. It was everything. For 380,000 years. Think about that duration. 380,000 years is longer than our species has existed. It is longer than any human civilization by more than an order of magnitude. It is, in human terms, an incomprehensibly long time. And for all of it, the universe was a featureless glowing plasma, opaque, uniform, filled with sound waves, actual acoustic waves, pressure variations moving through the plasma. At more than half the speed of light, the universe literally ringing in those first hundreds of thousands of years the way a struck bell rings, though no ear existed to hear it. These sound waves left their mark. They compressed the plasma slightly in some places and rarefied it in others, and when the universe finally cooled enough for atoms to form, when the electrons and protons combined into neutral hydrogen and the universe became transparent, these slight density variations were frozen in place. They became the seeds of everything. The regions that were slightly denser attracted more matter, and over hundreds of millions of years the gravity of that small excess density drew in more gas, and the gas drew in. More gas and the density grew until eventually the gas was dense enough to heat up and nuclear fusion began and the first stars ignited. The moment the universe became transparent, the moment the light was freed, is called recombination. It is one of the most important moments in cosmic history. In an instant, cosmologically speaking, the universe went from opaque to clear. The light that had been trapped in the plasma for 380,000 years was suddenly released to travel freely in all directions. That light is still travelling. It has been travelling for 13.4 billion years. It fills the entire observable universe today, cooled by the expansion from the blinding temperature of a hot plasma to just 2.7 degrees above absolute zero, stretched from visible light into microwave radiation. We call it the cosmic microwave background, and it is the oldest light in the universe. When you look at it, when you point a microwave telescope at any part of the sky, you are looking at the surface of recombination. You are seeing the universe as it was 380,000 years after the beginning. Everything before that is hidden from us. The way the interior of a cloud is hidden, the opacity of the early plasma is an absolute horizon, as impenetrable to light as the event horizon of a black hole. We cannot see earlier with any telescope that detects light, because light could not travel before recombination. But the cosmic microwave background is not featureless. It is almost perfectly uniform, the same temperature in every direction to 1 part in 100,000. But almost is not completely. There are tiny fluctuations, small temperature variations that map the density variations of the early plasma, the frozen record of those sound waves that rang through the universe in its first hundreds of thousands of years. These fluctuations have been measured with extraordinary precision, first by the COBE satellite in the early 1990s, then by double map, then by the Planck telescope. And they carry an enormous amount of information. From the pattern of temperature variations across the sky, cosmologists can extract the geometry of the universe, its age, its composition, the density of ordinary matter and dark matter and dark energy, the spectrum of the primordial fluctuations that seeded all structure. The cosmic microwave background is the universe's baby picture, and it is also a precision instrument, a way of measuring the properties of the cosmos with an accuracy that ground-based observations of galaxies cannot match. We are moving toward it now, not toward any particular direction in the sky. The cosmic microwave background surrounds us in every direction, a sphere centered on us, the surface of the last scattering. We are moving toward it the way you move toward a wall by shrinking the room. We are going back in time. The universe is becoming smaller and hotter as we go. The galaxies around us are growing closer together, their recession velocities reversing as we run the expansion backward, the cosmic web of filaments and voids compressing back toward the initial conditions. The galaxies themselves are dissolving as we approach their formation epoch. We are in the time before galaxies, the epoch of reionization, roughly 1 billion years after the beginning, when the first structures were still assembling, when the universe was filled with a fog of neutral hydrogen that the first energetic sources, the first quasars, the first massive stars were just beginning to ionize and clear. The universe at this time would look dark to human eyes if you were inside it. The first stars existed, but were spread thinly across a vast dark medium, their light struggling to penetrate the neutral hydrogen surrounding them. The cosmic dawn, the moment when enough stars and quasars had formed to ionize the surrounding gas and make the universe transparent again after a long dark age, was still in progress. It was a gradual brightening, uneven, spreading in bubbles around the first luminous objects, the bubbles growing and merging until eventually the neutral hydrogen was gone and the universe was clear. We are in the Dark Age now, the long stretch of time between recombination and the cosmic dawn, when the universe was filled with neutral hydrogen and helium and dark matter, but no stars, no light sources. No illumination of any kind except the slowly fading glow of the cosmic microwave background cooling from its initial brightness toward the cold it has today. The Dark Age lasted from about 380,000 years after the beginning to about 150 million years after the beginning. In that time, the density fluctuations were growing, dark matter was clumping under gravity, drawing ordinary matter with it, building the scaffolding that galaxies would eventually trace. But there was no light. The universe was dark and cold and quietly doing the gravitational work that would eventually produce everything. And then, the first star. Not the first star we know by name. Not a star in any catalogue, a star so early and so far away that we have not directly observed one yet, though the search is ongoing and the instruments are improving and the James Webb Space Telescope is. Looking harder than any telescope before it at the first light of the universe, hunting for the signature of those first stellar objects in the spectra of the most distant sources. The first stars are called Population 3 stars, a name that places them before Population 2 and Population the First in a backward counting scheme that reflects the order in which astronomers discovered the different stellar generations rather than the order in which they formed. Population 3 stars were different from any star that has formed since. The gas available to form them, the hydrogen and helium from the Big Bang, with almost no heavier elements, was chemically simple. Modern stars form in clouds that contain carbon, oxygen, silicon, iron, and dozens of other elements synthesized in previous generations of stars, and these elements change the thermodynamics of the collapsing gas, allowing it to cool more efficiently and fragment into smaller clumps, producing stars of a wide range of masses, including many small ones. Like our Sun, the first stars had none of this enrichment. They formed from pristine gas that could not cool as efficiently, and they formed differently, in larger, more massive clumps. The models suggest they were enormous, hundreds of times the mass of our Sun, some perhaps 1,000 solar masses or more. Stars so massive they burned through their fuel in only a few million years, a blink of cosmic time, and died in spectacular explosions that seeded the surrounding gas with the first heavy elements the universe had ever contained. Those heavy elements, carbon, oxygen, silicon, iron, all the elements heavier than helium produced in the cores of stars and scattered into space by supernovae, changed everything. They enriched the gas. They made the next generation of stars possible in a different way. And in the gas around those second-generation stars, for the first time, something new could form. Not just stars, but the residue of stellar formation, the dust and ice and complex molecules that eventually, given enough time and the right conditions, assemble into planets. Rocky planets. Worlds. The first potentially habitable worlds came late. The chemistry of life as we know it requires carbon, oxygen, nitrogen, phosphorus, sulfur, elements that did not exist in meaningful quantities until several generations of. Stars had lived and died and scattered their contents. The earliest Earth-like planets probably formed around 7 or 8 billion years after the beginning, in galaxies that had already processed their gas through multiple stellar generations. Our own Earth formed 4.5 billion years ago, 9 billion years into the universe's history, and was made possible by every stellar death that preceded it. You are the product of cosmic recycling on a scale that makes the word recycling feel inadequate. You are assembled from the ruins of stars. Every calcium atom in your bones was forged in the core of a star that lived and died before the sun existed. Every iron atom in your blood was created in a stellar explosion. The oxygen you breathe was manufactured in the nuclear furnaces of ancient stars and released when those stars ended. You are not separate from the universe looking at it from outside. You are the universe looking at itself from the inside. You are what the cosmos makes when it has enough time and enough recycled stellar material and the right conditions and the particular patience that 13 billion years of. Gradual complexification requires. The story of the universe is the story of matter learning to know itself. We are moving back further now, past the Dark Age, past recombination, back into the opaque plasma of the early universe, back toward the first second, back toward the conditions under which the lightest elements were forged. This period, the first few minutes of the universe's existence, when it was hot enough for nuclear fusion to occur in the bulk of the cosmos rather than in the cores of individual stars, is called Big Bang nucleosynthesis. For roughly the first 3 minutes, the universe was a nuclear reactor. Protons and neutrons combined into deuterium and helium and tiny traces of lithium. After 3 minutes, the universe had cooled enough that nuclear fusion stopped, and the composition was fixed. roughly 75% hydrogen and 25% helium by mass, with traces of lighter elements. This ratio matches what we observe in the oldest, most pristine gas clouds we can find, confirming that the model of the early universe is correct in its basic outlines. Everything heavier than lithium was made later. In stars, in supernovae, in neutron star mergers, those spectacular collisions of dense stellar remnants that produce gravitational waves detectable across billions of light years and in their aftermath. Synthesize gold and platinum and uranium and the other heavy elements through a process called the R process, rapid neutron capture. Neutrons slamming into atomic nuclei faster. Then those nuclei can decay, building up the periodic table's heaviest entries in the extreme environments of stellar collision. The gold in any ring, on any finger, anywhere on Earth, was almost certainly made in a neutron star merger. Two dead stars, spinning around each other in a tightening orbit, losing energy to gravitational waves over millions of years, finally colliding in a killer nova, a flash of light. Across every wavelength, an event visible across billions of light years, and in the debris of that collision, among the ejected material cooling in space, atoms of gold. Assembling from the chaos of extreme nuclear physics, and eventually drifting through space, and eventually being swept up into a forming solar system, and eventually sinking into a rocky planet's mantle, and eventually being brought to the surface through geological processes, and eventually being mined and refined and shaped into something small and circular. That carries all of this history invisibly on every atom in the nuclear record of where it was made. Something in the universe keeps a record of everything. The composition of a star tells you what generation of stellar recycling it came from. The spectrum of light from a distant galaxy tells you what elements are present there and how fast that galaxy is moving relative to us. The cosmic microwave background tells you what the universe was like 380,000 years after the beginning. Gravitational waves tell you about the masses and spins of the objects that collided to produce them. Neutrinos tell you about the cores of supernovae, streaming out from the collapse at nearly the speed of light, carrying more energy than the visible explosion. The universe is not silent. It is broadcasting in every medium available to physics, and we are only just beginning to build the instruments to receive all the channels simultaneously. The neutrino background, the cosmic neutrino background, a bath of neutrinos filling all of space, produced in the first second of the universe when it was hot enough to create. Them in enormous quantities has not yet been directly detected. Its existence is predicted with great confidence. The neutrinos are there, filling every cubic centimetre of space, including the space your body occupies right now, hundreds of millions of them passing through you each second. Without interacting, ghost particles from the first second of the universe passing through all of matter as if matter were not there at all. They have been travelling for 13.8 billion years. They are the second oldest relic of the beginning, after the cosmic microwave background. They are there, passing through the walls and the ceiling and the body lying still in the dark, and they carry no news that we can currently read. But the instruments are improving. They are always improving. And somewhere, in a laboratory deep underground where the rock shields out the noise of cosmic rays, someone has built a detector patient enough and sensitive enough to begin to see the faint signal of those primordial neutrinos in the data. It has not happened yet. But it is the kind of thing that happens when the instruments become good enough and the analysis becomes clever enough and the right person looks at the right data at the right time. Science is full of moments like that. The pulsar was discovered because a graduate student named Jocelyn Bell noticed something in her data that her supervisor had initially dismissed as interference. The cosmic microwave background was discovered by two engineers at Bell Labs named Penzias and Wilson, who were trying to eliminate a persistent noise in their antenna and eventually realised the noise was not a fault in their equipment, but the echo of the beginning of the universe. Dark energy was discovered by two teams of astronomers in 1998 who were trying to measure the deceleration of the cosmic expansion and found, to their considerable surprise, that The expansion was accelerating. The universe has a habit of revealing its deepest secrets to people who are paying close attention to something specific and small, and then suddenly find themselves looking at something vast and fundamental. And we are looking now, from inside the story, from within the long chain of cosmic events that began with the Big Bang and produced stars and supernovae and planets and the chemistry of life, and eventually produced something that can lie still in a dark room and think about where it came from. The universe made us curious enough to ask the question, and then gave us the intelligence to begin answering it, and then hid the best answers just far enough away that we cannot get to them quickly, that we have to work, that we have to build and measure and think and try again, that we have to stay curious for generations. We are very far back in time now. The universe around us is young and hot and featureless. The plasma glows in every direction. There are no structures yet, no galaxies or stars or voids or filaments, only the smooth hot sea of matter and energy, and the tiny variations that will become everything. The sound waves are still ringing, the plasma is oscillating, compressing and rarefying in patterns set by the initial conditions and the fundamental constants of physics. And these oscillations are the most ancient music in existence, the first organised variation in a universe that was otherwise a perfect symmetry. Perfect symmetry is another way of saying nothing. A universe that was perfectly uniform in every direction at every point would be a universe in which nothing could happen, because nothing would be different from anything else. And difference is the prerequisite of change. The tiny variations, the slight overdensities and underdensities imprinted on the early universe by quantum fluctuations in the inflationary period, were the universe's first departure from perfect symmetry, and from that departure everything followed. Every galaxy, every star, every planet, every living thing, every thought. Inflation, the period of extremely rapid exponential expansion that most cosmologists believe occurred in the first tiny fraction of a second, stretched those quantum. Fluctuations from microscopic to cosmic scale. Whatever was varying on the scale of quantum mechanics was blown up to the scale of the observable universe, and the pattern of that variation is the pattern we see in the cosmic. Microwave background today. We are looking at quantum mechanics written across the whole sky. We are seeing the imprint of the smallest scale of physics on the largest scale we can observe. The universe in its first moment connected the very small to the very large in a way that has been echoing ever since. The inflationary period itself is still a theoretical framework rather than an established fact. The evidence for it is strong. It naturally explains several puzzling features of the observable universe, including the uniformity of the cosmic microwave background across regions that should never have been in contact, and the flatness of the universe's spatial geometry. But the specific mechanism of inflation, what drove it, what kind of field caused the rapid expansion, and precisely when it ended, is not known. There are dozens of inflationary models in the literature, each making slightly different predictions, and distinguishing between them requires measurements of the cosmic. Microwave background's polarization at a precision that current instruments are approaching but have not yet fully achieved. The answer is coming. Not tonight. But it is coming. We are so far back now that the universe is seconds old. The plasma is so hot that protons and neutrons are still being created and annihilated in the heat, the temperature too high for them to persist as stable particles. We are in the quark-gluon plasma epoch, when matter was not yet organised into protons and neutrons at all, but existed as a sea of quarks and gluons, the constituent particles of the strongly interacting world, free roaming in a heat that prevented them from binding into the composite particles we know. The universe was, in these first moments, simpler than it is now in its composition of fundamental particles, but far more extreme in its conditions, 1 billion degrees of temperature in the first second after the beginning. The density of nuclear matter spread uniformly through all of space. And before that, before the quark epoch, before the electroweak epoch, before any of the named periods of particle physics, cosmology, there is a wall. The Planck time. 10 to the power of negative 40, 3 seconds after the beginning. Before this moment, our physics breaks down entirely, not because the universe was doing anything that physics cannot describe, but because we do not yet have the physics to describe it. General relativity and quantum mechanics, our two best theories, are incompatible at the energies that prevailed before the Planck time. Both of them fail. Both of them produce nonsense. The quantum theory of gravity that would describe those first moments does not yet exist. The universe keeps one more secret then, right at the very beginning. A pocket of unknowing so small in time, 10 to the power of negative 43 seconds, and so fundamental in nature that it may contain the answers to the deepest questions. We can ask, why does the universe exist at all? Why are the fundamental constants of nature the values they are? Why is there something rather than nothing? These questions live behind the Planck wall, in the region where our current understanding cannot go. But we have come very far tonight. From a dark room to the beginning of time, from the familiar to the fundamental. From the day's concerns to the oldest questions the universe poses. The journey has carried us to the edge of what is knowable and shown us what lies beyond. Not emptiness, not silence, but more questions. Beautiful ones, patient ones. The kind of questions that wait through entire careers and entire generations of scientists and entire centuries of instrument building before they yield their answers. And when they yield them, they yield something richer than anyone had expected. The plasma is still glowing. The sound waves are still ringing through it. The tiny fluctuations that will become galaxies and stars and everything are there in the pattern of the heat, too small to see directly but present, real, already doing their work of being slightly different, of being the universe's first departure from the featureless perfection it began with, from a departure so small, from a difference so slight, from a variation in temperature of 1 part in 100,000 in a hot plasma 380,000 years old. Everything, every galaxy that ever blazed, every star that ever burned, every planet that ever assembled from the cooling debris of stellar formation, every ocean that ever formed on a rocky world in a habitable orbit, every living thing that ever moved through any of those oceans, every mind that ever looked up at a night sky and wondered what was out there. All of it traces back to the same tiny variation. All of it is the universe working out the consequences of that first departure from uniformity, following the physics forward through 13.8 billion years, assembling and disassembling and reassembling matter into forms of increasing complexity, producing at last something that can lie very still in a quiet room and trace the whole. Chain backward to its source. The plasma glows warmly in all directions. It is enormous, and it is everywhere, and it is the whole universe, and it is very old news arriving very freshly in the instruments of every astronomer who has ever pointed a telescope at the microwave sky. The oldest light. The first message. Still travelling, still arriving, still telling the story of how the universe was when it was young and hot and undifferentiated, and everything was still possible, because nothing had yet been decided. Nothing had yet been decided. The galaxies were still potential. The stars were still potential. The planets and oceans and chemistry of life were still potential. You were still potential, written in the quantum variations of a hot plasma, billions of years from being assembled, billions of years from lying in a dark room with the day, released and the body still and the mind beginning to follow the story wherever it goes next, into whatever quiet the universe has prepared on the other side of the long dark. That follows a journey this far and this deep. The plasma is cooling now. Not quickly, not in any way that would be felt as a change from moment to moment, but cooling the way everything cools when the source of heat is no longer adding to it. The way a room cools after the last light is switched off, gradually and completely and without drama. The universe is expanding. The expansion carries the heat away from itself, spreads it thinner across a growing volume, and in the spreading it diminishes. Temperature is a measure of the energy density of a system, and as the volume grows, the density falls and the temperature falls with it, and this falling is the arrow of cosmic. Time moving forward, the universe aging in the only direction aging goes, we have traced that arrow back to its beginning tonight. We have stood at the edge of what is knowable and looked into the plank wall and felt the genuine humility of not knowing what is on the other side. And now the journey turns. Not back the way we came, there is no back. Not exactly. Not in the way a road goes back. The journey turns the way a tide turns, the way a long exhalation turns into the pause before the next breath, the way waking turns into sleep, not a reversal but a continuation. In a different mode, moving in the same direction but changing what that direction feels like. We are moving forward in time again, slowly. The plasma cooling around us into the first neutral atoms. The universe becoming transparent. The light breaking free. This moment, recombination, has a sound to it in the imagination. Not an explosion. Not a flash. Something quieter. The way silence sounds different in an open field than it does in a closed room, the universe going from one kind of nothing to another kind of nothing, from the opaque nothing of a plasma to the clear nothing of a transparent space, and in that transition, the light simply continuing, which it had always been trying to do, which the physics had always permitted if only the temperature would allow it, and at last the temperature allowed it, and the light went. In every direction simultaneously. The same light that is still arriving at our instruments today, 13.4 billion years later, cooled and stretched and redshifted into the microwave, still carrying the pattern of the plasma's last moment of opacity, still mapping the acoustic oscillations that rang through the early universe, still telling the story of what the cosmos was, like in its infancy to anyone patient enough to listen. Patience is what the universe rewards most consistently. The patient accumulation of data. The patient refinement of theory. The patient waiting for the instrument to improve and the analysis to mature and the answer to emerge from the noise not all at once but gradually, the way a photograph develops, the details appearing slowly out of the blank, first the broad shapes and then the finer structure and then the details that change everything. Astronomers are patient people. They study objects that move on timescales of millions of years. They build instruments that take decades to conceive and fund and construct and launch and calibrate. They work on problems that will not be solved in their lifetimes, and they work on them anyway, leaving the data organized and the methods documented for whoever comes next. The tradition of astronomy is the longest continuous scientific tradition in human history. People have been recording the positions of stars and the movements of planets for thousands of years, and every observation adds to a data set that now spans millennia. And the longest baselines in that dataset are the most valuable, because some things only reveal themselves over very long times. Variable stars. The precession of the equinoxes, the proper motion of nearby stars across the sky. The long period oscillations of the sun. Things that change slowly enough that a single human lifetime is too short to see the full pattern, but that reveal themselves clearly when you have records spanning centuries or millennia. The universe operates on many timescales simultaneously, and the ones that exceed a human life are not inaccessible. They are just expensive in the currency of generations. You have to be willing to start a project you will not finish, and trust that someone will continue it. This is a kind of love. Working on something larger than a life. Leaving the instruments pointed and the data flowing and the notes readable for whoever comes next. Trusting the future with the work because the work is too important and too large to fit inside anyone present. The universe itself does this. It works on timescales that exceed any individual thing within it. Stars live longer than anything on their planets. Galaxies live longer than their stars. Black holes live longer than their galaxies. The cosmic web of large-scale structure evolves on timescales longer than the current age of the universe, its filaments still thickening, its voids still emptying, the slow. Gravity-driven sorting of matter into walls and clusters, and the spaces between them still very much in progress. We are moving through the cosmic web now, in the imagination, at a scale where individual galaxies are points of light, and the structure between them is visible, the filaments. Like luminous threads, each thread containing hundreds or thousands of galaxies, the threads connecting at nodes where galaxy clusters sit like bright knots in a net, and between. The threads and the nodes the voids, the great empty spaces that fill most of the volume of the universe, relatively free of galaxies, relatively free of matter, hundreds of, millions of light years across. The voids are not truly empty. They contain a small number of galaxies. They contain gas, thin and diffuse. They contain dark matter, tracing the same web structure but more smoothly, less concentrated in the filaments. They contain the cosmic microwave background, which fills all of space uniformly and cares nothing for the structure of the web. And they contain dark energy, the energy of empty space itself, present wherever space is present, driving the expansion that is slowly pulling the filaments apart, slowly. Thinning the web, slowly moving the universe toward a future where the web will be too stretched to be visible as a structure, and all that remains will be isolated island. Galaxies in an expanding void. That future is billions of years away. The web is still intact. The filaments are still building, still accreting matter, still drawing galaxies toward the nodes through the slow influence of gravity operating across hundreds of millions of light years. We are still in the era of structure formation. The universe is still mid-sentence in the story it is telling with matter and gravity and time. And the sentence is very long, the longest sentence anyone has ever tried to read. 13.8 billion years long so far, and still going, every moment adding another word, the grammar of physics determining what words are possible, the initial. Conditions of the Big Bang determining which of the possible words were chosen, and the result, the observable universe as it actually is, the particular arrangement of galaxies. And filaments and voids and dark matter and dark energy, and the specific history of stars and planets and life that has played out within it, is one sentence out of all the sentences that the grammar permitted. Why this sentence? Why these initial conditions? Why these constants? Why is the universe the particular universe it is, rather than some other universe that the same physics could have produced? This is not a question with a consensus answer. Some physicists invoke the multiverse, the idea that all possible initial conditions are realized somewhere, that our universe is one of an enormous or infinite collection of universes, each with different properties, and that we find ourselves in one that supports life because life can only exist in universes that support it. The way you find yourself. On a planet, rather than in empty space, not because planets are more common, but because you require a planet to exist. This is the anthropic principle, applied at cosmological scale. Others find this unsatisfying. A theory that explains everything by invoking infinitely many unobservable universes is a theory that cannot be tested, and an untestable theory sits uneasily at the edge of what science can do. The debate is ongoing. The question is real. The answer is not yet known. But the question itself is extraordinary. That matter arranged into a form we call life can ask why the universe is the way it is, that the universe can generate, from its own processes, something capable of questioning its own existence. This is not nothing. This is, in fact, one of the most remarkable facts about the cosmos, Not that it is large or old or physically extreme in various ways, but that it is self-reflective, that it contains observers, that from the quarks and leptons and fundamental forces, given enough time and the right conditions, something emerges that can look back at the quarks and leptons and fundamental forces and ask what they are. We are that emergence. Lying still in the dark, the day released, the body heavy and slow, the mind floating somewhere between the room and the beginning of time. We are what the universe assembled from its simplest components over 13.8 billion years, and we are here doing what the universe assembled us to do, which is to wonder. The wondering does not stop. Not completely. Even in sleep, the mind continues some version of its processing, its sorting, its making sense. Dreams are the mind working without supervision, following associations and images through landscapes that the waking logic would never permit, finding connections that the careful daytime attention misses, the way a river finds paths through a landscape that no engineer would have chosen. The sleeping mind is not absent. It is different. It is doing other work. The universe at its most extreme does something similar. Inside the event horizon of a black hole, where we were last night, falling through the interior toward the singularity, the physics works differently. The equations describe a space-time that the outside universe cannot access, a region doing its own processing, following its own geometry toward its own conclusion, disconnected from the larger context but not thereby absent. The black hole is still there, still massive, still spinning, still affecting everything around it through its gravitational influence. The interior is hidden, not gone. Sleep is not absence. The dark behind closed eyes is not emptiness. The quiet of a body finally still after a long day is not the end of anything, but the beginning of something else. A different mode of the same continuing process. The mind, moving through different territory by different rules toward a rest that is also a kind of work. The universe is resting and working simultaneously. The great voids emptying slowly while the filaments thicken. The old red dwarf stars burning at a fraction of the sun's temperature for 100 billion years, while somewhere else a massive blue star blazes through its fuel in 1,000,000 years and dies spectacularly. The cosmic microwave background cooling by tiny fractions of a degree per billion years, while in a distant galaxy cluster 2 galaxies are colliding in a slow-motion merger that will take hundreds of millions of years to complete. Everything on its own timescale, everything in its own mode. The universe is never doing just one thing, nor are you. The body lying still is circulating blood and processing the day's proteins and consolidating the day's memories into long-term storage and regulating temperature and continuing. The 10,000 quiet processes that keep a living system living. The stillness is not stillness all the way down, it is stillness at the surface. Underneath, the work continues as it has continued every night of your life without requiring your attention or your will. You can trust it. You always could. The cosmic web drifts past in the imagination, its filaments catching the light of 1 billion galaxies, its voids holding the negative space that makes the structure visible. The whole enormous pattern turning imperceptibly slowly on scales that no single creature will ever fully see. It is beautiful the way mathematics is beautiful, not because it resembles something familiar, but because it is exactly what it is. Precise and inevitable and real. The first stars burned, the heavy elements scattered, the planets formed, the oceans gathered. The chemistry of life organized itself over millions of years of patient molecular trial and error into something that could replicate and vary and compete, and over billions of years become something that could think. And the thinking thing looked up and saw the stars and asked where they came from. And the universe, patient as it has always been, began to answer. Not all at once, not in a single revelation. In data, in patterns, in the light that has been travelling toward us since before we existed to receive it, arriving now and now and now, carrying news from distances and times that no living thing will ever physically reach, crossing the void to land in the instruments we built to catch it, whispering what it knows into the mathematics of those who know how to listen. The light is still coming. The cosmic microwave background fills the sky tonight as it has every night, invisible to unaided eyes but present, real, the oldest thing that can be seen. The universe's earliest message still in transit across every instrument sensitive enough to receive it. The gravitational waves from ancient mergers are still passing through the Earth, still moving the mirrors of the detectors by fractions of a proton's width, still carrying their news from collisions that happened before the sun existed. The universe is still talking. And you have listened, tonight, more deeply than most people ever do. You have gone back to the beginning and traced the long chain forward, and felt the weight of 13.8 billion years of cosmic history in the particular way that comes, when the body is still and the mind is loose, and the distance between here and the edge of the observable universe has collapsed to nothing, the way distance collapses in a dream. The way everything far becomes near when the mind stops insisting on the difference. The plasma has cooled completely now in the imagination. The universe around us is the universe as it is, old and spacious and still expanding, the galaxies moving apart at their steady accelerating pace, the filaments doing their slow gravitational work, the black holes at the centres of galaxies spinning in the dark, the stars burning through their long hydrogen lives, the planets turning, the oceans moving in their tidal rhythms, the living things on at least one small world going about the brief and extraordinary project of being alive. And one of them is lying still. The day is very far away. The beginning of time is very far away. Everything is very far away, and also, somehow, present, the way everything you have ever known is present in sleep, not accessible, not organised, not available for use, but there in the background, in the deep storage, available too. The dreaming mind in ways the waking mind cannot fully predict or control. The universe keeps everything too. In the nuclear composition of every atom, in the orbital parameters of every body, in the temperature and polarization of the microwave background, in the positions and velocities and spectra of billions of galaxies. Everything that has happened has left a mark somewhere, and the marks accumulate, and the universe carries them all forward through time, without losing a single one. A perfect record of everything that has ever been, written in physics, legible to those who learn the language. The language takes a long time to learn. A lifetime is not quite enough. But a lifetime is enough to begin. To learn the first words. To hear the first sentences. To understand enough to feel the shape of the larger thing being said, even if the full meaning remains just beyond the edge of understanding. The way a piece of music can move. You before you know its structure. The way a landscape can feel significant before you know its history. The universe is significant. You have always known this, not known it the way you know a fact, but known it the way the body knows warmth, directly, without argument, without proof. The vastness is not threatening, the age is not alienating. The smallness of any one life in the context of all of this is not diminishing. It is clarifying. It puts things in their proper proportion, which turns out to be a proportion in which everything matters at its own scale and nothing needs to be larger than it is to justify its existence. You are exactly the right size. The stars are exactly the right distance away. The darkness between them is exactly as deep as it needs to be. And the quiet that is coming now, the quiet that has been coming for the last hour, that the story has been moving toward the way a ship moves toward harbour. Still moving, but slower, the destination no longer a direction but a presence. something felt before it has arrived at. But quiet is exactly what it is. Not empty. Full of everything the journey carried, the plasma and the first light and the dark age and the first star blazing into existence in a universe that had never seen fire before. The cosmic web spreading its patient filaments across hundreds of millions of light years. The quasar blazing at the centre of a distant galaxy. The event horizon crossed without drama, without a wall, just a threshold and the continuing fall. The singularity ahead in time. Patient as everything the universe produces. Waiting without waiting. A feature of the geometry rather than a destination anyone chose. All of it is here. In the quiet, in the body that is finally, deeply, completely still. The universe is 13.8 billion years old, and it is still making things. Still producing stars and planets and the chemistry of complexity. Still sending light across distances that dwarf all human scale. Still keeping its deepest secrets behind horizons that the instruments are slowly, patiently approaching. There is so much still to find. Tomorrow night, if you want to return, the universe has more to show you. Stranger places, deeper questions, older light. The journey has only just begun.